When you're traveling somewhere new, chances are you're going to use a map. Maps come in all forms. Some are colorful with little pictures, some have ways of showing different altitudes, and some have the sole purpose of showing state or national boundaries. Either way, just like the spot on a map can tell you information about that location, the position of an element on the periodic table can help you predict some of the element's properties. An element is a pure substance, made up of only one type of atom. Elements are the building blocks of all matter, just like the letters are the building blocks of all words. There are currently 118 known elements represented on the periodic table. Some are found in nature, and others are created in laboratories. Each little block on the periodic table represents one element. Some examples of elements are gold, oxygen, neon, potassium, and tungsten. Each different element has atoms with a different and unique number of protons. This is called the atomic number. Because there are so many elements, there needs to be a system of organizing them. This is where a Russian chemist by the name of Dmitry Mendeleev comes in. In the late 1800s, when only 60 or so elements had been discovered, Mendeleev decided to arrange the elements in order of increasing atomic weight. While doing this, he also organized them so elements with similar characteristics were grouped together. In doing this, it was necessary to leave some blank areas in his organization, which later ended up being spots for elements that hadn't been discovered yet. What this means is his system of organization worked out so well that he could predict both the weights and the properties of undiscovered elements. We are still using this organization today in the periodic table. However, elements are currently organized in order of increasing atomic number. As Mendeleev was arranging the elements in order of increasing atomic weight, he noticed that patterns repeated periodically. Each time a pattern started over, he started a new row. A period on the periodic table is really just a horizontal row. The current periodic table has 7 periods, with an island of 2 periods down below. Why is that little island down there? It's really just because if those 2 rows were put into the periodic table where they belong, the table would take up so much space and not easily fit onto a piece of paper. You know how sometimes Alaska gets put into a different location on a map of the United States. Alaska is not really found below California. It's just there to save space. So when you're using the periodic table, just keep in mind where they should belong. The top row of that island is in the 6th period, and the bottom row is in the 7th period. Also, you may find that some periodic tables do show these 2 rows in their correct location. The vertical columns on the periodic table are called groups or families. Groups probably come in most handy when predicting the properties of an element. Just like people in a family all may share similar traits, elements in the same group on a periodic table also will have similar properties. The groups are numbered from 1 to 18, from left to right, and some of the groups have special names. For example, excluding hydrogen, all the elements in group 1 on the very left-hand side of the periodic table are called the alkali metals. Alkali metals are soft and silvery and react violently with water to form an alkaline or basic solution. Alkaline earth metals are found in group 2 and are shiny and silvery white in color. Moving all the way over to the right-hand side of the table, in group 17, you will find the halogens. Halogens are all very reactive and poisonous, which is why you may find these bacteria killers in bleaches and disinfectants. The elements in the last group on the periodic table, group 18, are called the noble gases. Noble gases are all colorless, odorless, and extremely unreactive. Their inability to react easily makes them a prime candidate for gases in light bulbs. Just like some maps show boundaries between states, some periodic tables have a staircase on the right side. This staircase separates the metals from the non-metals. Metals are found on the left side of this line, and they all have very similar properties. They're shiny, they're good conductors of both heat and electricity, they're malleable and ductile. Malleability and ductility refer to the substance's ability to be deformed without cracking. If your car gets dented, it's because it's malleable. If it were to crack, then it would be brittle. Most of the elements on the periodic table are metals. Elements to the right of the line are called nonmetals. Nonmetals are brittle in their solid form, dull, poor conductors of heat and electricity, and have much lower melting and boiling points than metals, which is why many of them are gases at room temperature. Some elements have properties of metals and nonmetals. These elements are called metalloids, and they're found on the staircase line. Elements that are most commonly referred to as metalloids are boron, silicon, germanium, arsenic, antimony, and tellurium. Silicon is the element that is found in computer chips. If you have ever looked at a computer chip, you may have noticed that it's shiny like a metal. However, if you were to ever hit a computer chip with a hammer, you'd find that it's very brittle, a property of nonmetals.